this lesson, the first step in our implementation was going to be part of the existing unit of work inside of the command handler, which means that we need to run this interceptor before the call to save changes executes. The old implementation was executing after save changes has completed, and the new one is going to execute before saving changes and is going to persist the outbox messages in the database together with any existing updates in the same database transaction. Now I'm going to also include this call here as part of our new method, and I can get rid of the old override to saved changes async because we will no longer need it. Let's rename this method to be insert outbox messages because this is what it's going to do, and this won't be an async method, so we can make it void. Another thing we could do is to make this method static because there are no instance types that it's going to access, and then let's see how we're going to fix the implementation. The first thing I'm going to do is get rid of the old code that was resolving a custom service scope, getting a publisher, and then publishing the domain events one by one. And I'm going to add another select statement here once we have selected a collection of domain events, and I want to convert each domain event into a new outbox message. We're going to set the identifier of the outbox message to the domain event identifier. And this is how we will be able to track domain event execution across our modules. We can also set when the domain event occurred from the respective property on the domain event instance. Then I'm going to set the type property by saying domain event get type, and we can take the name of this type. And then the content is going to come from serializing the domain event. So I will say JSON convert, and you will notice that I installed Newtonsoft JSON into the common infrastructure project, and we can say serialize object. And let's pass in the domain event. And I'm also going to pass in an instance of JSON serializer settings. And this is a static read-only instance that I created in the serialization folder inside of the common infrastructure project. And I want to configure type name handling to all so that we also include the type of the domain event when we are serializing it into JSON. And this is going to help us deserialize this type into an iDomain event instance when we are querying from the outbox table. So now let's rename this into outbox messages because this is now a list of outbox message types. And now all we have to do is say context. Let's grab the outbox message database set, and we can say add range and pass in our list of outbox messages. And this is going to include the outbox messages into the change tracker, which is going to cause them to be saved in the database as part of the current transaction. So now that our insert outbox messages interceptor is implemented, let's go ahead and move it into the outbox folder and adjust the namespace of this interceptor. I'm going to get rid of the interceptors folder because I will no longer need it. And now let's start working on the background job for processing our outbox messages. I'm going to install a new NuGet package into the common infrastructure project, and I'm going to look for Quartz. This is an excellent library for scheduling background jobs, and I'm going to install the Quartz extensions hosting NuGet package. Now that we have Quartz installed, let's go and update the infrastructure configuration to set up some base services that we are going to need for executing Quartz background jobs. And I'm going to start by introducing the Quartz services. And right now I don't need to configure anything additional, just calling add Quartz is enough. Another thing we should do is add the Quartz hosted service, which is going to help us run our background jobs using the hosted service abstraction inside of ASP.NET Core. And another setting that I like to configure is wait for jobs to complete and set it to true, which is going to wait for any background jobs to complete before shutting down the current process. Let's close everything down because we won't be needing it for the next step. And let's move over to the users module where we are going to make some updates in the infrastructure project. I'm going to add a new folder here called Outbox, and I'm going to start introducing a few types into the Outbox folder, starting with the Outbox options class. This is going to represent our options object where we can configure how often we want to run the Outbox job, and we are going to set these values using our application settings. And we can also configure what is the batch size for the Outbox processor, and this is going to represent how many Outbox messages we process in one execution of the background job. And now let's go ahead and introduce the most interesting component for our implementation, which is the process Outbox job. I'm going to make this an internal and sealed type, and how you create a background job with Quartz is by implementing the iJob interface. This interface contains only one method called execute, and this is where we are going to write our outbox processing logic. One thing I'm going to do at the start is disallow concurrent execution for the background job, because I only want one instance of the background job to be running at any given point in time. And then let's see what we need to do inside of the execute method. First, we need to get a collection of unprocessed messages. Then we need to iterate through the messages and publish them one by one. Lastly, we need to update any processed messages, and we can complete one run of the process outbox job. Let's go ahead and introduce a few dependencies that we are going to need to implement this. I'm going to start with an IDB connection factory that's going to help me interact with the database. Then I'm going to need the iService scope factory that's going to help me publish my domain events using Mediator. I'm also going to need an iDateTime provider so that I can pass in the time when the outbox message was processed. Then I'm going to inject an iOptions of outbox options, which contains my outbox configuration values. And lastly, let's include an iLogger of process outbox job so that I can add some contextual information while processing the outbox messages. I'm also going to add a private constant string representing which module we are currently in, and this is going to be the users module. And then I'm going to introduce a few helper methods that I need to implement my outbox. The first thing I need is an internal type to represent an outbox message response. This is going to be something that I will return from the database, and I'm going to add a helper method that's going to return a list of outbox message responses from the database. I will call it getOutboxMessages async, and this is going to help us implement the first step of the execute method. Of course, you can grab the code snippet for this method right under this video, and let me walk you through what we have here. I'm creating our SQL string. It's going to select the identifier and the content of our outbox message, and notice that we are querying from the user schema and the respective outbox messages table. This is important because when we duplicate this job across our modules, we will have to update the schema that we are querying. We are looking for any jobs where the processed on time is null, and we are sorting the outbox messages so that we process them in ascending order. I'm adding a limit of how many outbox messages we are returning using the outbox options batch size property, and I'm also adding a for update clause to lock these rows from any other transactions until I am done processing the outbox messages. Next, we are executing this using Dapper, and I can return the outbox messages from this method. Now let's go ahead and use this inside of our execute method. I'm going to start by writing an information log, and let's say module, and this is going to be our structured log property, and I'm going to write beginning to process outbox messages. And let's pass in the module name as the value for the module placeholder. Then I'm going to create a new database connection using my database connection factory. So let's say open connection async. And after that, I'm going to create a new database transaction using the connection that I just created. So I will say connection begin transaction async. We can go ahead and commit this transaction at the end of this method, which is going to be right after we have processed all of these messages. And then let's write another information log saying that we have completed processing the outbox messages. Now let's go ahead and query the outbox messages from the database using the helper method that we introduced. And let's say get outbox messages async. I'm going to pass in the connection and the database transaction, which are the required arguments. And after we get our outbox messages, we can say outbox messages for each and loop through the individual outbox message. Inside of the for each loop, I'm going to try to publish the outbox message using Mediator. Now this could throw an exception, and we are going to handle that case, and I'm going to rename this to caught exception. The first step inside of the try statement is going to be to obtain an instance of an iDomain event. And we are going to say JSON convert deserialize object, and I'm going to specify the iDomain event interface as the type that we want to get back. And then we can pass in the outbox message content as the string value that we are going to attempt to deserialize. And I'm going to pass in my serializer settings and the instance field that contains the appropriate JSON serializer settings. Let's go ahead and add a null forgiving operator because I'm not expecting this to be null. and we are going to catch an exception if it is null in any case. So this is something I'm okay with doing. And then let's create a new iService scope. So let's say service scope factory, create scope, and then we are going to use this service scope to resolve an instance of the iPublisher service. So I will say var publisher, and then let's say scope service provider get required service, and I want an instance of the iPublisher interface, which is coming from Mediator. I'm doing this because my domain events implement the iNotification interface, and I can then use publisher publish and pass in the domain event instance, which is going to execute the respective handlers for this domain event. I'm going to introduce a variable that's going to contain an exception. The default value for this variable is going to be null, and I'm actually going to update this value in case we catch an exception while publishing the domain event. Let's also write an error log in case we do end up catching an exception, and I'm going to log the exception that we caught. Let's add a message as well saying module, and then I'm going to write a message saying exception while processing outbox message. And let's add another value here that's going to be the message ID. And then we can pass in the module name and the outbox message identifier. So we end up including some additional information into the error log. After I have published my domain event or encountered an exception, we have to update this message inside of the database. So I'm going to introduce another helper method that's going to implement this functionality, and let's take a look at what we have inside. The name of this method is update outbox message async, and it's accepting an outbox message response instance and a nullable exception type. The SQL for this update is relatively simple. We're just updating a specific outbox message, and we are setting the processed on column and the error column in case there is an error where the identifier matches the one that we pass in as our argument. And then we execute this using Dapper, and of course we are going to call this method right here. So let's say update outbox message async. We can pass in the connection, the transaction, the outbox message instance, and the exception if we run into one while publishing the outbox message. Now I'm going to get rid of these comments, and this is our complete outbox message processor. Now I do want to make a few remarks here. The first remark is that we are using Mediator to publish our domain events. Now, as you well know, a domain event could have more than one handler, and what Mediator is going to do by default is it's going to do a for each loop between all of the available handlers and invoke them one by one. The side effect of this is that if any of the handlers throws an exception, then we are going to end up catching that exception here, and some handlers for a specific domain event could not execute if we run into an exception. So this is something that you should be aware of